In this video, we're going to talk about basic greatest common factor, which I sometimes like to abbreviate greatest common factor GCF. What this can do is simplify a problem, making it easier to factor with other methods later, or giving you the ability to solve a polynomial, again, either graphing it or making it easier to solve. So when we look at greatest common factor, we're going to look at each term, and the problem I have here, a cubed b to the fourth minus a to the sixth b squared plus 3a squared b to the fifth. What we want to do is look to see what is common in each term. Each of the terms have an a, each of the terms have a b. Some are positive, some are negatives. In this instance, we're not going to worry about the negatives, but we're going to look at the a's and the b's. So if we look at simply the a, we have a cubed, a to the sixth, and a squared. What I want to look for is something that's common in each of those, and in this instance it will be the a squared. If we look at the b's, we have the b to the fourth over here, b squared, and b to the fifth. That also will make the greatest common factor b squared. So what we want to do is look at factoring that out. And really what factoring is the ability to undo multiplication, sort of basically division. So for each of these, we're going to divide by a squared b squared. So each of these will be divided by a squared b squared. If there was a c somewhere, then that's not a common factor, so we leave it out. So if we divide the first one out, a cubed over a squared, that leaves us a as our remaining division. The b to the fourth over b squared, that becomes b squared. Remember, we subtract. Minus, we don't want to miss the minus. A to the sixth divided by a squared becomes a to the fourth. 6 minus 2 is 4. And b squared over b squared cancels out, factors out, so we don't have to worry about that. And then the third term, there's nothing to divide the 3 out, so we just bring that down. The a squared over a squared, those factor out or divide out, same thing as the b squared's head. And then the b to the fifth over b squared leaves you b cubed. Now to write this correctly, we need to make sure that we take into consideration that we had factored that out. So we have to put the a squared b squared outside of the polynomial. If you just include it as your answer, a b squared minus 4a plus 3b cubed, you're only going to get partial credit because you need to have the entire part, because this equation is still correct with that factoring outside. Well, we can also look at simple greatest common factors when we're only looking at numbers. So this particular problem, minus 16t squared plus 16t plus 32, we want to look for something that's common in each of the terms. 2 is common, 4 is common, 8 is common, but the greatest common factor is 16. Now, using just 16 will still be correct, but if we look at this first term, we've got a minus there. So we also want to factor out a negative. Makes it a little easier to work with. So we're going to factor out a negative 16. We can't factor out any of the unknowns because even though t squared and t have a common factor, the 32 basically has, in essence, t to the 0. So there's nothing we can really factor out of that. So if we take minus 16t squared divided by minus 16, we're simply left with t squared. If we take 16t divided by minus 16, we're left with minus t. And if we take 32 divided by minus 16, we're left with minus 2. And we can complete that. The last example will again be a greatest common factor. So if we look at each term, the 3x cubed minus 6x squared plus 18x, the common with the coefficients is 3. And what's common with x, or the variable, is x. So we can factor out a 3x, and then we can start our multiplication. So if we divide this first part by 3x, we're left with x squared. If we divide the second part by 3x, we're left with minus 2x. And if we divide the last one by 3x, we're left with 6. Now, if you divide two numbers, we know we can check those two numbers, that division, by multiplying. We can do the same thing with factoring. If we take this 3x, we can multiply it by each item inside the parenthesis to make sure that we have factored it correctly. So this becomes 3x cubed minus 6x squared plus 18x, and it checks out. One thing that some people have difficulties with is if the numbers cancel out. So we'll make this simple. So if we have a 3x squared plus 3x plus 3, the greatest common factor is 3, so we're going to factor out a 3. So x squared divided by 3 becomes x squared. 3x divided by 3 becomes x. 3 divided by 3 becomes 1. A lot of students just complete the multiplication, the factoring, and then when you check it, 3 times 3 times x squared and 3 times x, 3x squared plus 3x. We missed that last term. So what we really need to do is put the pen back, put 1 back there. So then if we multiply them through to test it, we get the last term again. So we always need to go back or get back to where we started. So that's simple greatest common factoring. You'll use this a lot to simplify a polynomial, especially later when you're going to do some more advanced factoring.